So this is a follow-up video. In this video we'll be looking at graphing regions. So again, if you remember, I told you to treat these inequalities just like equations. So here are the inequalities. If I write them all out first. Okay, put the graph, put the axes on. This is all on your sheet. Okay, and then find the E. Okay, so we're going to treat each of these inequalities like equations. So the first thing you're going to do is draw the line y equals 3. Okay? The line I've just drawn there is the line y equals 3. Okay? So, right from here, I have made the line a dotted line. The reason I've made it the line a dotted line is because y can't be 3. If you look at the inequality, y is less than 3. Okay, so I've drawn, undo that. I've drawn the line y is equal to 3. I've made it dotted because y can't be 3. So if we look at the region where this is true, since y is less than 3, the region where this is satisfied is anything below the line. So for example, this point here would be satisfied. This point here is 10, minus 3. And 10 minus 3, well, that point there, y is less than 3, so yes, that point is correct. So anything below the line is satisfied. So what I'm going to do for this particular question, because we're going to be graphing lots of lines, and ultimately I'm going to find the region where all of these inequalities are satisfied, I'm going to shade the bit I don't want. So I'm going to shade the bit I don't want. Oh, right. Hold on. So the bit I don't want is this bit above the line. Okay. And I've just shown there y is equal to 3. Anything below it is the region I want. So the next line we're going to look at is y is equal to 2. We're going to draw that line y is equal to 2. So yeah, I've drawn the line y is equal to negative 2, sorry I meant negative 2, and then we're going to leave this line as a solid line because if you look at the inequality, y is bigger than or equal to minus 2, so since it could be minus 2, I leave the line as solid. And now you can see I've drawn an arrow just above y is bigger than minus 2, y is equal to minus 2, and that's because our region is anything now above this solid line. So if we combine those two regions, our line is anything above the purple solid line but anything below the black dotted line. And so if I shade the region I don't want now, I don't want that region below the line. Okay, so I only want the stuff within that strip. And any coordinate within that strip satisfies our two inequalities so far. Whew. Next. I'm going to focus on C. So I'm going to draw the line y equals x minus 3. You might want to pause the video now and draw that line yourself. Okay. So if we're looking at plotting this line y is equal to x minus 3, you know the gradient is 1, and you know it crosses at minus 3. Okay? So gradient 1 and y-intercept is negative 3. So that is the line there. Okay? Now, it's a solid line because y is greater than or equal to x negative 3. The bit of the equation that you want, well, y is bigger than that line, so it's anything above the line. So I'm going to shade the region I don't want. Okay? So this is the line y is equal to negative 3, and I shade the region that I don't want. So you can see the empty space left is the stuff where all the inequalities are satisfied. Right, we'll do another one now. So if you want to pause the video and try and plot the line 2y plus x is less than 8. Okay, if you weren't sure how to do that, this might help you. You need to rearrange, you need to make y the subject because you only really know how to draw y is equal to mx plus c graphs. So make y the subject. Okay, so you could pause the video and try and make y the subject of that inequality now. Okay, from here we could say 2y is less than 8 minus x, and carrying on we can divide by 2, so y is less than 4 minus a half x. So for this particular question, the gradient is -1/2 and the y-intercept is 4. So you might want to draw that now. Okay. So y-intercept is 4, gradient is -1/2. That's what this line looks like. And you can see that the gradient is -1/2. It's going down, it's a sloping down graph. Okay. And it's a dotted line because if you look at the inequality, it's less than, but not equal to, so it becomes a dotted line. Now y is less than that graph, so I'm going to shade the bit above the line, because I want all the stuff below that line, so I'm going to shade the bit I don't want. Finally, if we look at e, x is bigger than or equal to -2, so you're going to draw the line x is equal to -2, so do that now. Okay, once you've done that, you should have a straight vertical line there. Okay, a straight vertical line at x is -2, and it's a solid line because x could be -2, and you shade the region you don't want. So since x is bigger than -2, we shade all the stuff that we don't want, which is to the left. And so finally, the stuff that's left over, the empty space, with those dotted lines there, that region is satisfied by all the inequalities. If you were to pick this point, say here, at 1, 1, and you were to check that point against all the inequalities, that would satisfy them. So if you look at A, y is 1, so yeah, y is less than 3. Y is 1, so yeah, y is greater than -2. X minus 3, well that's 1 take away 3. Okay, 1 take away 3 is -2, and yeah, that's less than y, which is 1. 2 times 1 is 2, plus 1 is 1, and that's less than 8. So 2 times 1 plus 1, so that's 3. And then finally, 1 is bigger than -2. So it all makes sense. Okay. We'll go through some of these questions in lessons. So really, all I want you to be able to do is plot the equations as you were doing before, and then just to be able to shade the regions that you don't want effectively.